All right. So we just created the best spot illustration we could digitally with vector line art, coloring behind. I added color holds and then an offset behind so it looks really clean on any background. We kind of tested it by bringing it up to a site like Redbubble and trying it out on all these different kind of products. Right? So the next phase is to understand what's called color separation. So what we've done so far is to make what are called one-offs, like a prototype. So if I decided, okay, this is my spot illustration design, great. This is the product I want to make that I'm going to sell to, people at DemocracyCon, right? 2025. Now I need to realize I'm not going to make each of those on Redbubble because Redbubble is a print on demand, kind of like our printer is a fine art printer, and they just print on different products rather than just on paper, right? Problem is, they're a lot more expensive per unit because the inks are super expensive because you're printing thousands of colors, right, in mixed dots of ink. So if I was actually going to sell this at a convention, basically whenever you want to make more than 50 of something, you don't want to have to do print on demand. I want to get that per unit cost to more like $5 instead of $25, right? So to do that, I need to turn it into a professional print job. And for a t-shirt, that would be a silkscreen. Now, I'm going to pause for a second and pass around silkscreen examples. All right, so a print-on-demand product prints with all the kind of inks that our fine art printers print with. And they're expensive per unit. So this shirt would be about $25, $24, right? If I want to get it down to about $5 a shirt, I need to make it in a professional silkscreen. And to do that, I open up the file. And to simplify this, I am going to close this, make sure I save my multi-layered PSD. And I'm going to go to the file that I put up to Redbubble in the first place, which was the PNG, the same one that went to Canvas, right? Why PNG? Because it's transparent. But I'm going to open it now with Photoshop. I'll do Photoshop 2025. And now, how do we separate out this image so that it will work for a professional printer? And I can know how it will work instead of being surprised by how it looks when it's finished. Okay, the first thing I do is I need to separate it into what are called channels. So you'll see next to layers, it's been there the whole time because it's for professionals. Channels. Channels is the way, I don't want to watch this video. Okay, channels is the way the computer sees your image. Right now your image is in a mode which is the default Photoshop mode, which is RGB. RGB stands for 3 colors. Do you know what they are?
Red, green, blue.
Red, green, and blue. So sure enough, what we're seeing is the red, green, and blue lights of your computer screen making up all of these images. If I turn off the eyeball on some of these channels, you'll see how they mix, right? So if I take just the blue lights and then add the green lights, that gives me yellow. So when green and blue are at 100% opacity, not even opacity, luminance, because they're turned intensity, that's the term. So the lights are turned on to their highest point, you get yellow, right? When blue is turned on and green is turned off, you get blue. When green is turned on but blue is turned off, you get green. And then all the variations in between. When they're both turned off, what do you get? Gray or black, right? Because these are based on light. RGB are the light primaries. This is the light pigments. And that's how your computer screen sees. So then when I add in red, I get millions of colors just from those red, green, and blue lights. Let's add red and blue together. And that gives me all my pinks, right? Let's add green and red together. That gives me my really intense yellows and oranges. So it's Not very intuitive. And it has nothing to do with printing because light is different than pigment. So the first thing I need to go is go to Image, Mode, and we're going to change it from RGB color to something called CMYK color. Now CMYK stands not for colors but for inks. It stands for cyan, magenta, yellow, black. The K is black so you don't confuse it with blue. Cyan is different than the blue that's in RGB. Magenta is different than the red that's in RGB, right? So if I change it to CMYK color, it's going to ask me if I'm sure because it's going to limit a few of the millions of colors I can see. So could you tell that shift? It's very subtle. I'll go back in my history and go between it. So that's RGB color. RGB. This is CMYK color. Very, very similar. But the difference is now look at your channels. Your channels are now based on printing and based on the colored inks you can print with. So the first is black. These are all the black inks that would need to be printed. This is the black with the yellow. This is the black with the magenta. And this is the black with the cyan. Now you add them up. Here's the cyan, the magenta, and the black. And it kind of makes more sense, right? You get all the variations you would think you would get from mixing blue with pink and black. And then if I add the yellow in there, I get the full spectrum. What if I take the magenta out? What if I take the cyan out? So what I passed around was very much one with the magenta printed and then one without the magenta printed, right? Okay, here's the problem though. When you isolate any one channel in CMYK or in RGB, you don't see color anymore. It goes to grayscale. Why is this? Well, because the computer is binary. The computer knows it can either turn on a light or turn off a light, right? So this is actually how the computer codes those different channels. It codes them in terms of whether they're turned off or turned on. In this case, because we're in CMYK, where they're black means it's turned on. Does that make sense? Because that's where you need the ink. But this is bright red. So why is it filled in with solid black? Because that's the magenta channel. Because you need 100% printing of magenta where you have the bright reds in the illustration. Okay, here's the other problem. When you print with ink, like what I passed around, you don't get to have grayscale, right? So if I printed this with a silkscreen or with a lithography press, all of that would just be filled with that magenta color. So how do I separate grays into solid dots of ink? This is what's called CMYK halftone separation. So this is what I would need to do. I am going to take that magenta layer. I am going to delete the other layers. You don't need to do this. I have it actually programmed for you how to do this. And then I'll show you in our class Dropbox, you can download the program to add into your own version of Photoshop. But basically, I'm going to take that single layer and I'm going to change its mode from color to grayscale. And that will flatten it. Right? So now there's only one channel, and that's gray. Now I'm going to change that gray, and I'm going to change its mode to a word we've seen before, but this is its true use, bitmap. Bitmap is going to change all those grays to be only turned on or turned off. Either they have ink or they don't have ink. So then I get what's called this dot separation screen, and I'm going to use halftone because that's what I'm teaching you. Halftone is like bricks in a wall. Okay, what's the output I want? Well, I might as well match the output to what my pixel resolution is. So these are going to be really tiny dots. Or really cleanly made dots out of a lot of pixels. So then what's the frequency? I'm going to leave the frequency really large. So 20 per inch, right? That's like worse than, that's half the quality of the one I passed around, which was 45. And then it's going to ask for an angle, right? We're going to get into that. So let me just run this. This is magenta. So now you can see there are only black pixels and white pixels. this is the film work. But if you get a distance from it, you can see all those grays. So that's how you print the computer data of the channels. So this is making it professionally print ready. So I'm going to show you how we do this. You go right from your RGB PNG. You go to layers, you make sure it's only one layer. And then I'm going to show you what's called an action. So you go to actions, and you're going to load my Karl color separation actions. And then you're going to run CMYK full run. And what that will do, you just press play, is it will separate out a different file for each of the film works needed for your color illustration. So I have black, magenta, yellow, and cyan, and it will give you a combined layer where they're each a different layer that you can play with. Now remember, we did this at a really low quality so you can see those dots. But this is where the angles come in. So I'll use the two most obvious angles. Black, and this is what you need to know about halftone theory. Black is always rendered at 45 degrees. This is where halftone gets its name. So where can we see that most clearly? You see these dots? You see how they're lined up horizontally? But as you move down one step, they shift over by half, like bricks in a wall. So what their angle is actually 45 degrees. 45 degrees is where they're lined up perfectly, in sync with each other. Yellow, which is the lightest color, we use the least flattering angle, which is 0 or 90 degrees. So you see the dots for yellow, and they're just lined up horizontal and vertical. Why is yellow always horizontal and vertical? Because it's the lightest of the print colors, it's the one you see the least, and it's the least flattering print angle. Why is black always 45? Because it's the darkest of the ink colors, it's always printed last, and it's the angle you're going to see the most, and 45 is the most flattering. So when they mix together, like here, because they're on those two different angles, you see how they are offset from each other. This is why it's called offset printing. Now when I add other colors in, they're at different angles. They're at 30 degrees off of black, 15 degrees off of yellow. So there's the cyan, and then the magenta fills in, so that they're all just off of each other enough, just like the little pocket pal diagram, that when they all come together, they form what are called Gaussian roses, where you'll always see a little bit of each color, even in the black line art, to give you that effect. Now what's fun is I can take all of those, I can close the rest, because I like this in my own work. It's something you can play with if you want. I'll show you how you can load the actions. And I learned this technique from DC Comics, how to do this, because this is kind of what professional printers will do. Okay, and now I can take that and I can add it to my original illustration, right? I can take, because all of these are just pixels, and I can merge them into a folder, and then I can move that folder onto here. Oh, that didn't work. That's how it works in Photopea. So here we go. Move it out, and then drag and drop the folder on, and then just move it to fit. Now my default action is for professional printing standard, not my studio standard, so it's at 300, which I actually do intentionally, because when I grow this, it's going to soften those really, really harsh pixel edges a little bit. So I grow it and line it up. And what I also like from this kind of halftone theory is it really matters how you line things up. So you get what are called misregistrations, right? So if I like that, what I can do is I can take the black lines here, and I can just move those separately a little bit from everything else.